Okay, I think we're currently recording. All right, so factoring. There is a variable involved in the factoring, and you might be looking at this. Maybe some of you are going, what the heck's a variable? Variable is a letter that we use in math to take the place of a number. And this is all letters, but the X, hi, congratulations.
Thank you.
That's so exciting. The X is the actual variable in this problem. The A, the B, and the C are just kind of like the numbers that float in front of it, okay? So this is sort of the general form of what we call a quadratic expression. This is a quadratic expression. All right? Oh, you need paper, hey? Okay. All right, so quadratic expression. The variable doesn't have to be x, as you see in the very first example. This variable is v. To make it quadratic, it'll have a squared variable, a first power variable, and then a term with no variable at all. It's called a trinomial. There are quadratic expressions that are missing one of the variables down in the difference of squares. We'll talk about that shortly. But I'm going to go through 3 different methods with you. And method 1 is guess and check. Have any of you been taught the guess and check method? Yeah, okay. So guess and check is exactly how it sounds. What I need to do to this trinomial is to break it down into 2 binomials so that when I distribute it back together, I would end up with the trinomial that I started with. And so to do the guess and check method, what I have to do is just try things that are going to help me make my way through to get these values. And so, for example, the first thing that you do when you multiply is you'll multiply the 2 front terms. And so let's say, for instance, I put 3v and 3v down. That would mean I would get, when I multiply these together, 9v squared, which is what I want my front term to be. Okay? I could also do 9v and just v, because that would also get, when I multiply the front 2 terms together, 9v squared. Good? Makes sense? Okay. I'm not going to do 4.5v and 4.5v, because even though 4.5 and 4.5 add to be 9, I need to multiply them to get 9. So a lot of times I'm really restricted in the numbers that I can use. And in this case, I only have 2 choices, 3v and 3v or 9v and 1v. When you have bigger numbers, if I had 24v squared, I could do 1 and 24, 2 and 12, 3 and 8, 4 and 6, blah, blah, blah. You get what I'm saying, I hope. Okay? Now, the other thing I need to do is to get this end number. And I'm not going to start writing it in yet. I'm just going to, above 28, write all the ways that I can get 28. So above 28, that's supposed to be like one of those little pointer things. Okay, above 28, I could multiply 1 and 28, or 2 and 14, or 4 and 7. Good? And so what I'm going to do is I'm going to start moving things around and seeing what I can do to get a combination of outer, inner, meaning if I put, and I'm just going to randomly put a number, like let's say, this isn't necessarily the answer, I just want to go through it. Let's say I just tried 2 and 14. 2 and 14, okay? So I would take 3 times 14, and 3 times 14 is like 42, and 2 times 3, which is 6, and 42 and 6 would have to combine or add to 43, and it doesn't. So I know that this 2 and this 14 aren't going to work. All right, so my guess and check is going to be moving these around. Now, some people have a real hard time with the guess and check method because you have to play around with the numbers. What I usually do is I'll take a little piece of paper and I'll just kind of set it down by the number that I'm working with. And I'm going to work with 9 and 1 or 3 and 3 on the left-hand side. And I'm going to work with 1 and 28, 2 and 14, and 4 and 7 on the right-hand side. And I just start multiplying. 9 times 1, I'm going to point my fingers at what I'm multiplying together. 9 times 1 is 9. 1 times 28 is 28. Is there anything I can do with 9 and 28 to get 43? Is 9 plus 28 43? Is 9 minus 28 43? No. So that's not going to work. Then I'll do 28 and 9 and 1 and 1. Well, 28 and 9 is way too big, so I already know I can skip that one. Then I move down to the next one. 18 and 14. Is there anything I can do with 18 and 14 to get 43? That's 9 times 2 and 1 times 14. 18 and 14. Anybody? 43? No. Okay. So then I'll flip it the other way. 9 times 14 and 2 times 1. Well, that's already too big. Again, 9 times 14 is way too big. It's over 90 because 10 times 9 is 90 and 14 is bigger than 10. So I know I'm not going to do that. Then I'll try the next one. 36 and 7. Is there anything I can do with 36 and 7 to get 43? I see some nods. 36 plus 7 is 43, right? So that means that I have to multiply the 9 times 4 and the variable by itself times 7. So I'm going to put that down here. This is the guess and check. I'm going to do the 9 times 4. So 9 gets multiplied times 4. And the 1 times 7, that means the 1v gets multiplied times 7. Now I just have to pick signs, and our first one was a nice one. It was an easy one to work with because it's all plus. That means my signs are plus. That's my only option. So this would be my final factored form for that answer. Again, my intentions on doing guess and check was not to confuse you, so I hope that it did not cause too much confusion. And if you feel like, what the heck did she just say? Then just rewind, wipe this out of your brain, and pick one of the other methods. One of the other methods are a little bit easier to kind of work your way through slowly, okay? Does anybody think they like guess and check? Okay, good. I use it sometimes, especially when it's smaller problems. But when you get bigger numbers, I'll go to a different method. So method number 2 is, I don't want to use purple, I already used purple. Grouping. And so grouping takes a different approach. It's a little bit more organized. And so when I factor by grouping, I'm going to take this 9v squared plus 43v plus 28, and I'm going to work with, for starters, the product of 9 and 28. So what is the product of 9 and 28? Does anybody have a calculator handy? They can help us out with that one. I think it's 152? 252? Okay. So off to the side, I think of 252 as my number that I'm looking at. And again, I'm going to take another piece of little paper here, and I'm going to start writing down factors of 252. Now, in this method, if you are organized, your life can run very smoothly. If you're a little like maybe you jump around a little bit in your mind, things get a little more tricky. So I highly recommend that you Just either take your calculator or your brain and just start listing factors in order. I always start with the smallest factor pairs. So the smallest number is 1. 1 goes into everything, and I look at 1 and 252. Is there anything I can do with 1 and 252 to get 43? No. So then I'll look at 2. So I do 2 times what is 252. That means I'll take 252 and divide it by 2. So what's 252 divided by 2? Anyone?
126.
126? Great. Is there anything I can do with 2 and 126 to get 43? No. So then I'll try 3. Does 3 go into 252? So I take 252 divided by 3?
Yeah.
It does? What do you get?
84.
84. Is there anything I can do with 3 and 84 to get 43? Then I'll try 4. Does 4 go into 252? Yeah, how many times?
63.
63. Is there anything I can do with 4 and 63 to get 252? No. Okay. So then I'll try 5. Does 5 go into 252? Nope. So I'm going to ignore that one. I'm going to slide this up a little bit. How about 6? 6 and
42.
42. Is there anything I can do with 6 and 42 to get 43? Nope. So I'm going to move up here because I'm running out of room for you guys to see. I'll try 7. Does 7 go into 252?
Yeah.
Yeah, how many times?
36 times.
36. Is there anything I can do with 7 and 36? Yes. So that's the pair that I'm going to work with. So what I do is I rewrite the 7 and the 36 as 7v plus 36v, and I cram it in the middle in place of the 43v. So this becomes 9v squared plus 7v plus 36v plus 28. Get those out of the way. So that's how I rewrite this. This is my new problem, and now I'm going to do the grouping part of it. The grouping part of it is factoring the pieces. I'm going to factor this first chunk. What can I take out of 9v squared and 7v? V. So this is v times 9v plus 7. And then this is plus, so plus. What can I take out of 36 and 28? 4. So this is 4 times 9v plus 7. This is the indicator that I'm on the right track. Because I got the same thing for both of those, this 9v plus 7 gets factored out and written once in front. And then what am I left with? V plus 4. Notice the same answer. One was just sort of guessing as we went. The other one was a little bit more organized. Has anybody been taught grouping before? Does that look familiar? Okay. You probably recently had Algebra 2, or did you have Algebra 2 in 8th grade? Last year. Okay. Because I know that that's what they started leaning towards last year. Do you like that method, or does it? You like that one better? Okay. All right. So that is the by grouping method. Here's the last one. And again, as we go, you might change your mind in terms of what you like, but our last method is the snowflake. This is a good one. The reason that I like snowflake personally is because it's sort of a foolproof way. It works pretty nicely no matter who you are. Okay? So you don't have to really overthink things. So the snowflake requires you to draw a little snowflake. I accidentally picked that blue, but it seems so appropriate for a snowflake, doesn't it?
It does.
Yeah, thank you, thank you. Okay, and so up on the top, you write the front times the last number. So 9 times 28, that's that 252 that we looked at before. Does that ring a bell? Okay. So it's the front times the last again, that 252. And then, I should write that down here, 9v squared plus 43v plus 28. That top comes from that product of those two. And then the bottom is the 43. And then I put a 9v and a 9v on the, I call them the upper wings. So the 9v and the 9v. Now the reason I do 9 is because the front number is 9, and the reason I choose v is because the variable in the problem is v. A big mistake that I see people make is they want to put 9v squared and 9v squared. Try not to do that, okay? It's just the number in front and the variable used are what go there, okay? And then we do the same thing that we kind of did for the grouping. We can use that same process. I'm going to find two numbers that multiply to be 252 and add to be 43, and so I'll go through this same organized process until I find the pair. And we happen to already find them for grouping, so we'll put those in for that lower portion, 7 and 36. Now here's where, again, sometimes errors can be made, and so you have to be a little bit careful. One or both of those wings will be able to be simplified. So always make sure that at least one, sometimes both, can be simplified. So I treat this like a fraction. Is there anything I can take out of 9 and 7? No. Is there anything I can take out of 9 and 36? Yes, 9. So I'll cross that out. This makes this 1v, when I divide that by 9, and 4. And hopefully you can start seeing this come together. This is parenthesis. This becomes my first part of the answer, 9v plus 7. And what's left after I reduce becomes my second part, v plus 4. Again, 3 different methods, all the same answer. My goal in doing this was not to confuse you. Again, I just want to show you there are options. There is not one right way or one wrong way, but there is one right answer. And so you want to make sure you pick a method that works best for you, that you feel most comfortable with, and practice that method until you can become pretty good at it. Because you will be factoring all the way throughout this term, and next term, and if you choose to go on into calculus, you'll be doing that again. It's like just something that doesn't go away anymore, all right? Okay. Special cases, a difference of squares. I talked about a trinomial. Sometimes you have squareds as a binomial, and a difference of squares comes in the form of a front number squared and a back number squared. And the general rule for this guy is, and it's a difference of squares, meaning it has to have a minus. There's no sum of squares. It doesn't work for a plus in there. It's a difference of squares, but when you break it down, it's a plus b times a minus b. It's the square root of the front plus the square root of the back times the square root of the front minus the square root of the back. Difference of squares, if you recognize them, become quite easy to do. Remember how long these took? Right, you were there, you saw. These took forever to do. And sometimes they do. Difference of squares, piece of cake. I make my parentheses. I figure out what the square root of 4x squared is. What's the square root of 4? 2. What's the square root of x squared? So this is 2x plus, what's the square root of 49? Great. And then I rewrite it again with a minus between. How do you feel about those? Those are pretty good. Yeah, those aren't bad. Did you guys remember difference of squares? Anybody remember seeing those a little bit?
I vaguely remember.
Vaguely, yeah. From years back?
Oh, yeah.
Okay. All right. So, one thing that we have to remember when we are factoring, we've gone through kind of the basics of factoring and breaking down, but one thing that we do have to remember is you want to pull out a greatest common factor first if you can. And so when you look at your problem, before you even start setting up whatever method you're going to do, guess and check, or snowflake, or grouping, or whatever, look at it closely and see if there's anything that you can take out of all three numbers. Is there anything that comes out of 20, 205, and 50?
5.
5. Great. So we'll go ahead and we'll take out a 5. And then I'll rewrite this as 4x squared plus, looks like 41x plus 10. All right. Now I'm going to factor this in the method of my choice. I will take the first suggestion I hear. Great, snowflake it is. Okay. So I am going to multiply the front and the last, and that gives me a 40. The middle is the bottom, 41. I make my wings. I put the 4x and 4x in the upper wings. And then I go through in my brain. I need two numbers that multiply to be 40 and add to be 41. And if I can't think of it right away, I'll start listing the factors. Well, it turns out the very first factor pair that I can list is the one that I'll use. Does it matter if you put the 40 first or the 1 first? Not at all. Not in the least. There's no reason why I put it one way or another. Just depends on what I'm feeling at the moment. I'm a free spirit. Okay. So then I have to look to see, remember, at least one of these can be reduced. At least one. And it looks like for this one it's on the right-hand side again, so x and 10. And so now I can write my final answer, but I do not want to forget that GCF in the front. It doesn't just vanish. It goes in the front of the answer, so my final answer looks like this, 5 parentheses. Then I'll take 4x plus 1, x plus 10. And I put my little bubble around it, and I call it an answer. Now, so far on this sheet, I have only done things, or most of the things that we've done have been plus, like addition all the way through. And in fact, our last one is the same, but we're going to run through some practice problems where the signs are going to change, and you'll see how those work, how you treat them. You'll treat them as positive or negative numbers. But before we do that, I do want to talk about problems that might be deceiving. And one of them is like this next example. It sort of looks like a difference of squares because 4 is a perfect square, right? 36 is a perfect square, and if you're looking at it, you might recognize it. The problem is this is not a difference, it's a plus. And so I don't want to jump into it and think right away, oh, it's just 2x squared plus 6x and 2x squared minus 6x. It won't work that way. The plus doesn't follow that same rule. So there are going to be occasions where you only have a GFS, only a greatest common factor. And when you do that, you'll pull out what they share. What does 4x to the fourth and 36x squared have in common?
4x squared.
Beautiful. So the 4x squared goes out in front, leaving me with an x squared, because 4x squared times x squared would give me 4x to the fourth. plus 9 because 4x squared times 9 would give me the 36x squared that I want. And then there's nothing more that I can do with this problem, even though, again, this looks like a perfect square, like a difference of squares. It's got a plus in it, and so there's nothing I can do. All right, so it looks like phones have not been caddied, and that's partly my fault. So I'm going to pause this for a second, and we are going to go and get people to put their phones in the caddy, because I see some people playing with theirs right now. So give me a second, and I'll tell you the number. Plus, it's a good time to take a little break, and then you can stretch your legs while you walk to your phone spot. Oops, I hate this. All right. So Glenn, yours will go in number 1, Ella in number 2, Corinne number 3, Morgan number 4, Liv number 5, Noah number 6, Caleb number 7, Ryan 8, Lara 9, Hayden 10, Ava 11, Nora 12, Riley 13, Tommy 14, Matthew 15, Carolyn 16, Natalie 17, Charlie 18. Do you have a sister, Natalie, who's a freshman? Oh, sorry. Do you have a sister, Natalie, who's a freshman?
No.
No? Oh, I have another Pitts. Right, Mackenzie. Would she be a relative? Not that you know of? Okay. Charles 18, Emily 19, Allie, I accidentally called you Alex earlier.
That's okay, it happens.
20, does it? It won't ever happen again, I promise.
Thank you.
Allie 20, Caitlin 21, Bria 22, Owen 23. Okay. Can you wait till after we're done with notes? We're just about, it's not, no? Okay. Go ahead. All right, so here we go back to our factoring. One thing that I want to point out, and one thing that people forget often, is there's a difference between something called factoring completely and factoring to solve. Factoring completely means we're doing just like what we did above. We're writing it in its broken down form. We call these prime factors, okay? And it's in its most factored form. There's nothing else that can be broken apart in that. Nothing else that can be taken out of anything. When you factor to solve, however, you are actually going to be solving for the variable. So you're going to be getting answers. In this case, the variable is A. And I generally know, like there's no secret about it, but I generally know I am going to be solving when I have an equal sign in it. So if you see an equal sign in the problem, typically the directions are going to say something like solve or find the zeros or something to that effect. If it doesn't have an equal sign in it, it will say factor completely. So that's the dead giveaway. But when you factor to solve, what you want to do is, for starters, get everything on one side. And you want to get it on the side that forces the squared term, meaning the a in the ax squared plus bx, that to be greater than 0. So you want it to be positive. Well, it is already positive where it is. So what I'm going to do is bring everything over by the 15a squared. And I'm going to do this really slowly right now, but when I do it on my own, when I'm doing it just to actually solve, I don't do it as slowly as I'm going to do now. So I'm going to add the 48a to both sides. The problem is There's nothing over here on the left for it to be added to. So I'm just going to write that as 15a squared plus 48a plus 38 equals 2. So I just brought the 48 over. It was minus, so I added it. I undid what was going on there. And now I'm going to do the same thing with that 2 because I still don't have it equal to 0. So minus 2, minus 2. It turns out that this time I do have something that it can blend in with. So this is 15a squared plus 48a plus 36 equals 0. So there is my setup answer to solve. I'm going to bring that over here. 15a squared plus 48a plus 36 equals 0. My next move is get the greatest common factor out. Is there a greatest common factor? Is there something that goes in 15, 48, and 36? Yeah. Beautiful. So I'm going to pull out a 3. This is 5a squared plus 16a plus 12 equals 0. And now we'll go ahead and factor this using the method of choice. Should we stick with Snowflake?
Yes.
Okay. So I multiply the front and the last. That gives me 60. The bottom is 16. That's that middle number. 5a and 5a in the upper wings. And now I'll start going through the factors. Some of you might be like, oh, I know it, I know it, I know it. How many feel like you know it, you know it, you know it already? Okay, good. But when you're going through, you'll just list the ways to get 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, until I find the one that's going to add to 16. And I need to be a little careful with that, add or subtract, but we'll play with those negative numbers in a little bit when we practice. So 6 and 10, so I'll put those in the spot and cancel what I can. Looks like, again, it just turned out that on the right-hand side is what I could cancel. Could take out a 5 out of both of those, so that's a and 2. And so my final answer is, not my final answer yet, the factored form is 3 times 5a plus 6 times a plus 2 equals 0. That equals 0 in there tells me that I need to go on and do a little bit more. I need to actually solve. So here is the final solve step. I take each of these factors and set them equal to 0. When does 3 equal 0? When does 3 equal 0? There's no variable in it, right? Yeah, so this is a never situation. That'll never equal 0. So it's a non-issue right now. I don't want to forget that it's there, because if there were a variable in it, there would be an issue. It would be a concern. We have to remember it's there, but right now there's not, so it's a non-issue. I can cancel that out. Then I do 5a plus 6 equals 0. And I solve this just like a little mini equation. Subtract 6. Divide by 5, and I get my first answer. So there's one answer. And then I'll set the a plus 2 equal to 0. Subtract the 2, and I get my second answer. A equals negative 2. So factoring completely and factoring to solve, when you get your homework, you will have both types on there. So please make sure you read the directions and answer the way you need to answer it for the instance that you have, or for that particular group, okay? But before we get that, I do want to do a little bit of practice where we throw in some sign changes. And so you have 2 sheets that you're going to get. This is just us practicing together before you go off on your own. So I'm going to ask a lot more questions now and get some help from you guys when we work through these. So where was the first place you went after that?
I left to go with my parents.
Did you? Where'd you go?
To the place in Wilmington.
Called? You can say none of my business if you want.
I have no idea what it's called. 'Cause
Okay.
I've never, wait, is it something with the Jim? I don't know.
With Jim?
Yeah.
Okay.
He's with one of our neighbors who owns it. I don't know
Oh.
anymore. He gave me a challenge and then we find it by ourselves.
You had to drive by yourself to get there? All right. Do you remember when you were a kid and you did Mad Libs? Remember that?
Yeah.
You're like, make a noun, and you always picked like gross words and silly stuff, and then you made a story with it. Does that ring a bell?
Mhm.
Okay. This isn't quite the same, but similar. You don't get to pick. We're going to find the answer, and then if you do it all right, you'll have the right little story at the end of the situation. All right? So we have some problems to work on, and then we also have some space to work. Oh, I should probably stop recording this now. It's like 3 hours later.